All right, today we are going to climb a pretty fascinating ladder, the one that leads to true AI reasoning. We're going to explore the incredible breakthroughs that are teaching artificial intelligence not just to talk like us, but to actually think like us. Let's dive in. This is the million-dollar question, right? For the longest time, AI felt like a really advanced parrot. It could mimic human language, sure, but that step-by-step logical reasoning seemed totally out of reach. But in just the last few years, something has fundamentally changed. So how are we finally getting there?
Just look at this chart. See that point right around 2022? It's not a gradual increase, it's a rocket launch. This shows the cumulative number of research papers on AI reasoning, and it tells us that a massive breakthrough happened right then, kicking off a complete gold rush to make AI smarter.
So when we say reasoning, what are we even talking about? It's not just about spitting out facts it memorized. As you can see here, it's a whole cognitive process, analyzing evidence, building arguments, and using logic to come to a conclusion. We're talking about a shift from a simple text generator to something that has a structured thought process. So what was that big breakthrough back in 2022? Well, you might be surprised. It's actually ridiculously simple, and it's the very first rung on our ladder. It all comes down to a trick we all learned in math class: show your work. Okay, look at this. On the left, a standard prompt. The AI gives an answer, but we have no clue how it got there. It's a total black box. But on the right, that's the game changer. It's called chain of thought prompting. By simply asking the AI to think step by step, its ability to solve complex problems just skyrockets. It's not just giving the answer, it's laying out its entire logical path for us to see. And the results are, well, they're stunning. This table shows how a powerful model does on some really tough math problems. With a standard prompt, it gets it right about half the time. Not great. But with chain of thought, the accuracy jumps by nearly 25%. And here's the crucial thing: forcing the AI to slow down and actually spell out its logic makes it dramatically better at reasoning. Chain of thought is powerful, for sure, but it follows one single straight line of thinking. So what happens when a problem has multiple possibilities, a few dead ends, and needs a little creative exploration? Well, a single chain just isn't going to cut it. And that brings us right up to the next rung on our ladder: exploring possibilities. To solve the really hard problems, AI needed to learn how to check out multiple lines of reasoning at the same time, moving way beyond a single train of thought. The solution is a technique called tree of thoughts. Instead of one single chain, the AI generates a whole tree of possibilities. It's kind of like a detective who doesn't just follow one lead until it goes cold. Nope. Instead, they explore multiple clues at the same time, constantly weighing which ones seem the most promising. So, how does this actually work? Well, first, the AI generates a bunch of different ideas. Then, and this is the key part, it evaluates each of those paths, deciding which ones look like they're going somewhere. Finally, it explores the best options, and it has the ability to backtrack if it hits a dead end. This gives it a systematic way to handle really complex problems without getting lost. Okay, so far, our AI has been a pure thinker, kind of stuck inside its own digital mind. The next giant leap on the ladder was to give it tools and senses, to let it actually interact with the outside world. You can think of a standard large language model, or LLM, as basically a brain in a jar, just like you see on the right here. It's incredibly powerful, but it's totally disconnected from the real world. Its knowledge is static, stuck with whatever it was trained on. And a brain without senses or tools can't really solve problems out here in the real world. It can't check its own work, it can't find new information, and it can't do precise calculations on its own. So, researchers built a bridge. Now, this diagram might look a little complicated, but the core idea is actually pretty simple. They created an interaction loop between the AI and an environment, turning it from a standalone model into a single agent system. Now the AI can take an action, get feedback or a perception from its environment, and then decide what to do next. It's not just a thinker anymore, it's a doer. So what can this new agent actually do? Well, it can be given tools. It can search the web for up-to-the-minute information, use a calculator for perfect math, or even run some code to see if a solution works. This just fundamentally expands what AI is capable of. And this isn't just a gimmick. As this quote from OpenAI makes really clear, solving actual, real-world challenges means you have to gather information from all over the place. Giving AI the tools to do that is absolutely critical. So we've climbed from step-by-step reasoning to exploring multiple paths and using tools. So what's at the very top of the ladder? What's the next frontier for all this? The frontier is the multi-agent system. And yeah, this diagram is dense, but the concept is all about collaboration. Instead of one AI working all by itself, we can now have entire teams of AIs. They can communicate, coordinate their actions, and work together to solve problems that are just too big for any single agent. The absolute best way to think about this is like you're putting together a panel of experts. You could have one AI act as the planner, another one as the coder, and a third one as the critic. They can debate different approaches, share what they find, and ultimately come to a much more robust and well-reasoned conclusion together.
But wait a second, all of this advanced reasoning, the chains, the trees, the agents, it must take an enormous amount of computation, right? It's like we're asking the AI to think harder, but that thinking costs real energy, time, and money. So what's the hidden cost of all this power?
Which brings us to this number, 47.3%. But this isn't a performance gain, it's a measure of potential savings. See, the next big frontier isn't just about making AI think harder, it's about making it think smarter. New research is focused on teaching AI to figure out how difficult a problem is and then use just the right amount of computational power. For easy questions, a quick, simple answer. For the hard ones, it can fire up all its complex reasoning tools, and that could reduce compute costs by nearly half without losing any performance. We started this with a simple trick from math class and climbed all the way to collaborative teams of AI agents. Each rung on this ladder unlocks brand new capabilities, and it leaves us with one final fascinating question. As AI continues its climb, what problems is it going to solve that we once thought were reserved only for the human mind?